So how this memorization can be done? Okay. So let us use one global array f. Okay, and indices 0, 1, 2, 3, 4, 5, and I will initialize all the values to -1. Okay. So when I call the function fib of 5, it calls fib of 3 and fib of 4, isn't it? So fib of 3, do we know the value? No. Next, fib of 3 calls fib of 1. Fib of 1, do we know the value? No. However, the fib of 1 returns me 1. Therefore, here I change it to 1. Okay. Next, similarly, fib of 2. So fib of 2 initially it is -1. So fib of 2 so this, okay, so till now this function is called, this function is called, this function is called, and here this function is called, and fib of 0 is called, which returns 0. So fib of 0 is called, so fib of 0, it returns me 0, and I will memorize that 0 in the index 0. Next, fib of 1, you need not to call fib of 1 because it is already called, and already the value of 1 is already memorized here. Next, therefore these two are added for fib of 2. So for fib of 2, so fib of 0 and 1, that is the value is 1. Okay. Next, so fib of 3, these two values are added, fib of 1 and fib of 2, which is nothing but 1 plus 1, which is nothing but 2, right? Next, fib of 4 is called, right? So fib of 4 is called, and in turn it calls fib of 2. So you need not to call this fib of 2 now because it is already called, and what is the value of fib of 2? It is 1, right? And fib of 3, you need not to call fib of 3 and in turn this, and here in turn this, you need not to call because already these values are memorized. So what is fib of 2? So fib of 2 is 1 and fib of 3 is 2. So 2 plus 1, that is 3, right? Next, fib of 5. So fib of 3 plus 4, it is 2 plus 3, 5. And that is how we can memorize the called values. So now you can see this function, how many times this fib is called recursively? 1, 2, 3, 4, 5 and 6, right? All these are not called. Okay. So for a value of n 5, n plus 1 number of times the function is called, isn't it? Therefore the time complexity now belongs to big O of n, which is linear. So compare this with the exponential. So there is a drastic reduction in the time complexity, correct? So this is top down approach because we start from the higher value, that is 5, and we go down till and we go on memorizing the values. Okay. However, in most of the cases the dynamic programming goes for the tabulation method, So in the tabulation method, which is again very easy, so we shall look at the iterative version. Okay, iterative version of the Fibonacci. So iterative version of the Fibonacci, so function something like this. So fib of n int fib of n. So I will use the array f. So f of 0 is 0 and f of 1 is 1. Then for I is equal to 2, I less than or equal to n, I plus plus, right? So it is f of I minus 2, right? So it is f of I minus 2, f of I is equal to f of I minus 2 plus f of I minus 1, correct? So here the array f is filled in this way, f of 0 is filled first. So what is f of 0? 1, 2, 3, 4. So f of 0 is 0, f of 1 is 1, then f of 2 is filled, f of 2 is filled, f of 3 is filled, f of 4 is filled, like this. So it starts from the 0th term and then goes to the higher terms, and hence it is called as the bottom up approach. Okay, so in dynamic programming, in most of the cases the tabulation method is used, and with this we reduce the time. See, here there is only one for loop, therefore the time complexity is in terms of n. The time complexity is in terms of n, which is big O of n. Okay, so whether it is a memorization or a tabulation method, the time complexity reduces to the linear in case of dynamic programming. Okay.